Understanding VMware Views architecture and components. Well, let's get to work. Before we can go anywhere, before we can really install anything, it's nice to have a nice big picture view of the whole thing that we're about to construct. And don't worry, we're going to get into button clicking. that's coming up. But before we get into any kind of button clicking, I feel like it's useful to see some picture of what this giant puzzle is intending to create. Right? How do all the things interrelate? Why do they exist? How how does this thing connect to this thing, and for what reason? So before we actually talk about clicking buttons, and don't worry, I've got an entire infrastructure here with vSphere servers and with VMware View administrator consoles to work with, and clients that have the VMware View client installed, and even some ESX servers here that we can all interrelate with. So all of this exists right here. Don't worry. But before we get into that, let's spend a minute actually taking a look at the architecture, taking a look at all the different pieces, because sometimes it's somewhat challenging to really understand, well, what's the interrelation between all the bits. There are kind of 4 or 5 major components that make up VMware View. All of this sits on top of the foundation that is vSphere. Okay, so my ESXi hosts my vSphere server, my vCenter server. All of that represents the hypervisor, the virtual environment that everything runs on top of. Now, on top of that are going to be a number of different servers, or really collections of services. The most important of which is the View Connection Server. Okay, that's kind of the central switching station for all of these connections between users and desktops. We also have a View Transfer Server, View Security Server, and a View Composer, or View Composer Server as well. I think it's probably easiest if I actually kind of start by taking a look at the whiteboard here, and on this whiteboard, helping you understand where all the pictures connect. Okay, let's build the picture of this infrastructure. So way back in the day, like a couple of years ago, when we think of a user's computer, we only thought of that in terms of a physical computer. Well, VMware View intends to replace that computer experience, or at least augment that computer experience, with a much more controlled environment that sits back in the data center. And so this whole notion of a user and their computer, the relationship between that user and their computer, changes quite a bit whenever we start involving a technology like VMware View. So I want to kind of put this little gray bar here to represent, this is essentially the split between what is the user's experience and then what is the administrator's experience in the background. Okay, so on the right-hand side, we'll talk about this being kind of the data center. Now, everybody thinks of View as being a VMware product, and pretty much everybody thinks of VMware products as ESXi, right? Today in vSphere 5, everything's ESXi. ESXi is kind of it's the really sexy part of the VMware portfolio. It's the thing that does all the virtualizing. But ESXi, while it's the host for our virtual machines, it needs a little bit of assistance in order to accomplish what it needs to do. And that is accomplished by this View Connection Server. It can be confusing because the View Connection Server and the View Composer have similar names, at least the same consonants with the E, or with the letter C between them. But again, that View Connection Server becomes that launching point for users to ultimately connect to their remote desktops, or to their virtual desktops. Now this, of course, brings up an interesting point, right? So I've got a user here, and somewhere down here is that user's virtual desktop. Well, unless we figure out some way to, plug that desktop into the user's brain, the initial point, kind of the on-ramping point for this virtual infrastructure, requires some sort of device that the user has to work with. So one of the very, very, very important concepts that I hope you take away from this nugget and from this entire series is that the implementation of a virtual desktop infrastructure, of desktop virtualization, does not mean getting rid of endpoints, does not mean getting rid of some sort of device that sits down at the user's cubicle. You have to have something that sits there to receive that desktop. Now that can be a stateless device, zero client. It can be a thin client, so a nearly stateless device. It can be an instance of Windows that's been locked down to do nothing but connect up to the virtual desktop. It can be a full version of Windows. It can be their laptop. So there are a lot of different options here for how you will end up ultimately providing that access for the user. But you're not going to get away from having to have some piece of technology that the user plugs into, because there's got to be a keyboard and mouse there somehow. So user talks to their device, and this should almost say user's device instead of user's computer. User's device talks to view connection server, and you, the view administrator, kind of sit up here and sort of control everything. All right, so here is your control as your view administrator over the entirety of the environment. The view administrator console in VMware View is handled mostly through a website, right? So you're going to go to a specific web page and a specific website to actually control most of VMware View. That's what this looks like. So this dashboard here is the location where you're going to work with users and groups and create pools and desktops and create persistent disks and tag thin apps to individual desktops and things like that. We will be playing with this throughout the entirety of this series. Plenty of time in that. Interestingly enough, the View Administrator Console, that website, doesn't do everything. There's a couple of command line scripts that we'll spend a little bit of time looking at. But it really doesn't do everything. Okay, so there is some recognition that you'll have to have some command line basis for some things in order to get everything done. So let me kind of scroll this over here so I can make everything fit. Now, the View Administrator here, when you go to create virtual machines, in the most simple of situations, what you're going to do within the View Administrator console is instruct View Connection Server to work with the ESXi servers. You, depending on which mode you use, may have to pre-generate those virtual machines before View Connection Server can actually bring them into a desktop pool. In the manual mode, you may actually have virtual machines that you've created inside of vSphere. And those manual mode machines are already pre-configured. There's no automations in their generation, but View Connection Server just facilitates making the connection from the user down to them because you've already created them. A common situation here is when you have, so in the previous world, when users were working with their physical computers, maybe you P2V'd those physical computers into the virtual environment. They exist as virtual machines over here in ESXi, and so consequently, you're just using View to facilitate the connection. That can be great, and many people kind of start down that path because it presents the ability to preserve the user's experience, their state data. There's not a bunch of extra layers in place, but it really kind of treats all those virtual machines as a very monolithic entity. Rule number one in desktop virtualization is that storage is generally always at a premium. And the more virtual machines that you have, the more expensive SAN storage you have to supply for them. That expensive SAN storage adds up over a period of time. And so having manual mode VMs, well, is sometimes not a great idea. The other tenet of desktop virtualization is the more streamlined the experience that you can create. So more leaning towards the classic task worker situation, generally the more success you're going to have and the more automations you're going to be able to implement into your desktop virtualization environment. When you have knowledge workers with high needs for customization, desktop virtualization begins to slip as the idea of, as the best idea. The more further separated or more forked your different individual VM instances get from each other, well, the less well they're going to work here in this virtualization environment, because virtualization likes snapshots, and snapshots like similarity, and similarity begets low storage consumption. There is a second type of deployment that we'll talk about a little bit later. And that second type of deployment is not the manual mode, meaning I have a bunch of VMs that I've already kind of have or created on my own, but there's this concept of full virtual machines. Similar to manual mode, but the virtual machines are actually created. They start their life from a template that exists here inside of vSphere. So here, if I look at vSphere, this is my vSphere server, we may actually work with a template like this W7-template here as an actual a vCenter template object inside of the vCenter server. From that, I can instruct my connection server to create clones, full virtual machines of that template. Again, each virtual machine is its own thing. There's no linkage here. There's no snapshot linkage here. There's no linked clones in this circumstance. So if I have 10 VMs and 10 VMs require 20 gigs apiece, well, I need 200 gigs to support that. That is the second of the three major deployment options: manual and automated with full virtual machines. The third one involves a joining of your vCenter server with this technology called View Composer. Okay, so here's that vCenter server that you would use to send instructions to your ESXi server. Well, whereas View Connection Server cannot be co-located with vCenter server, the View Composer server must be on the vCenter server. The reason for that is because this View Composer server actually facilitates, well, sending the commands over to the ESX hosts. These are things like snapshot, right? And what we're looking for here is the concept of linked clones. In a linked clone environment, I have one disk that is the golden disk, the disk by which all virtual machines, they come from. This disk, right? And when I create a snapshot of that disk, a differential, if you will, that differential is a very, very, very small disk that contains what's different between this VM instance and that VM instance. And so that's a very, very small piece of data. They have to be very similar, right? The more deviation I get from the golden image, the more storage space I'm going to consume. But if I manage to keep them relatively non-deviating, well, then I actually conserve that space. I can also, and this is kind of an interesting thing, you can actually integrate your environment, your whole View environment, not just with virtual machines, but with other desktop sources as well. These are commonly, these can be regular desktops, these can be Blade PCs, these can be terminal servers or RDS servers. Interestingly enough, VMware still in this version refers to them as terminal servers. The rest of us have been calling them RDS servers for forever. Although we slip from time to time and still call them terminal servers. My MVP is in RDS, and I still say terminal server. Those other desktop sources, the reason why they exist is because it may make sense for you to incorporate your Blade PCs into this infrastructure. Connect user and their computer up eventually to Blade PC, or connect user and their computer up to terminal server because you've got this nice client that's out there. Okay, admittedly, so compared to a Citrix, for example, where server-based computing is more integrated in with desktop virtualization, the integration here with terminal services RDS much, much less. So there is, all right, so now I've got the manual mode. I have the second mode, which is full virtual machines. The third mode, which is linked clone VMs. And this sort of special case, which is other desktop sources. Okay, this is a very large portion of that infrastructure that we are going to build, but it's not everything. Let's assume that this is not just a general break between the inside and the outside, but let's assume that this little gray bar is in fact a firewall, and these computers are not inside the LAN. They are in fact out on the nasty, dirty, internet somewhere. Being out on that nasty, dirty internet means that, well, when they connect up through some firewall, I don't want them to have any kind of direct connection. Goodness gracious, no, not into my internal pristine environment. I want to actually set something between those, the outside world and the inside world, to, I will use the term proxy, but to essentially kind of hold the gate, to be the gatekeeper for any of those incoming connections. That is what we call a view security server. It exists in a work group. It ends up having what we call a pairing password with an internal view connection server, but that view security server sits in a DMZ, more or less, and becomes the point at which outside computers end up talking to inside services. We will talk about that. It's very, very, very late in the game. The last piece is actually, here's where things really start to get kind of gray area with all of this technology. And the last piece is this thing we call a view transfer server. So throughout the entirety of this, this soliloquy to this point, we've been talking about getting that user connected up to their virtual desktop via some remoting protocol. Two protocols are available out of the box: Microsoft RDP, commonly associated with RDS, and also the PC over IP or PCOIP or Teradici protocol, which VMware purchased from the company called Teradici a number of years ago. We'll talk about the differences a little later on, but each has different features and reasons for being. And those protocols are important because they're designed to get the screen scrapes from the virtual machines out to the user's computer over whatever kind of connection may exist in a very thin manner. I want to keep the amount of network traffic as thin as possible between these two connections because, well, if it's on the LAN, it doesn't matter. I mean, it does, that it doesn't at the same time. But if out on the WAN, right, who knows what kind of connection I might be coming through? Some 3G, latent 3G connection. There does come the time, from time to time, however, when I might actually want that virtual machine not to be presented to the user's computer, but instead to actually run, to execute on that user's computer. Right? So I want the processors of the user's computer to process the virtual machine file, the VMDK file. I don't want to present it over the wire. I want it downloaded. And that's where we start introducing the notion of a view transfer server. Okay, what is a view transfer server? It's a giant file copying facility. These VMDK files are huge, 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 huge files. And so we need this view transfer server because it becomes the point of transfer between the user's computer and wherever their virtual machine may exist. It also becomes that sort of regular synchronization point. So when user makes change, I want to sync up any changes. So if they lose their machine, that I can still bring them down with a very recent copy of that machine. It's when you start talking about view transfer servers, the technology is sexy, don't get me wrong, but the use case begins to get a little confusing. So if I'm trying to incorporate desktop virtualization to get stuff back into the data center and then allow users to get stuff back out of the data center, am I kind of undoing what I was putting stuff in the in place in the first place? Again, the most important thing I want you to gather out of this nugget and throughout the entire series is that desktop virtualization is a component of your greater application delivery infrastructure. We'll talk about thin apps a little later on. We'll talk about RDS servers occasionally. Desktop virtualization is another piece in this very large puzzle of how you connect up users to the stuff that they require. Right? The desktop that is their container for applications and data. Well, how do I service the needs of those users best? Is it via a virtual desktop? Is it via a presented desktop through something like server-based computing? Is it via a streamed application or any of the other options that are out there today? So this picture here should serve to give you a representation of the entire environment that we're going to be building over the next 18 nuggets at this point. I hope you have an opportunity now to kind of see how all the pieces fit together. And admittedly, I'm soliloquizing here because this really is very important. And you won't understand where we're going in the next nuggets unless you understand where everything fits together. So what have we talked about in this nugget? We have talked about the view architecture and then the components that feed into that architecture. We talked about vSphere, the foundation of most of View. And then the connection, transfer, and security servers, which are three flavors of kind of the same thing. And also then the View Composer, which effectively allows us to, it facilitates the creation of all these link clone virtual machines, which today offer the greatest amount of automation for those virtual machines. Coming up next, we will begin with the click here, then click here by starting with the installation of that View Connection server. But until then, I hope this has been informative for you, and I'd like to thank you for viewing.